Hello, people. So, cartilage is a form of connective tissue. The main two elements of this tissue are cells. These cells, the main cells, are chondrocytes, and the second important element is the ECM, or the extracellular matrix. There are three main types of cartilage in our body. We have the elastic cartilage, the hyaline cartilage, and the fibrocartilage. First, the cartilage sits uh, on some connective tissue, so this would be connective tissue. This connective tissue has a few fibrocytes, few blood vessels, and then we have the cartilage. The first element of cartilage tissue is this layer, and this layer of cartilage is called the perichondrium. So the perichondrium of cartilage tissue is actually a layer of dense, irregular connective tissue. It surrounds the cartilage, and it also has these blood vessels and important cells called chondrogenic cells. So these are chondrogenic cells. And these cells have the capacity to differentiate into the cells that are underneath, and these are chondroblasts. So chondroblast cells. These are blood vessels. The chondroblasts then, if they are starting to produce matrix, the extracellular matrix, and when they get surrounded by this matrix, they become chondrocytes. And chondrocytes are the main cells of the extracell of the cartilage. These cells are about 10 to 30 micrometers in diameter. They have good developed organelles, and they can be less or more active, producing also parts of the ECM. This is the basic construct of cartilage. Some forms of cartilage don't have this perichondrium. For example, the hyaline cartilage in our joints does not have perichondrium. So the blood vessels in the perichondrium have the nutrient supply for these cells. With diffusion, it comes to all these cells. But in our joints, they don't have this perichondrium layer, so the chondrocytes get their nutrient supply from the joint and from diffusion from the synovial fluid that is in the joint. That's the difference. So the main three cells are chondrogenic cells that can differentiate into chondroblasts. Chondroblasts, when they develop this matrix, they become chondrocytes. So these are the three main cells. Besides them, the important element is also this extracellular matrix. And the matrix is different in these three types of cartilage. So for example, we see here, this is elastic cartilage. In elastic cartilage, we see that it has many cells, and besides collagen type 2, it has also elastin in its extracellular matrix. In comparison to hyaline cartilage, there are less cells, and hyaline cartilage only has collagen type 2 in its ECM, so this would be hyaline cartilage. Then the last is the fibrous cartilage, or the fibrocartilage. It has the least amount of cells, and it is sometimes hard to distinguish it from dense irregular connective tissue. But these groups of chondrocytes are a marker that it is fibrocartilage. Fibrocartilage also has not that much collagen type 2, but a lot of collagen type 1. So we see that the different amount of cells and the difference in the ECM makes a difference in the cartilage type. Now, if we would take this part, for example, and enlarge it to see it in detail how it is structured, we can see this part up here. This is the perichondrium. So this part is actually the perichondrium. These cells are progenitor cells or chondrogenic cells. Chondrogenic cells. These are collagen molecules. So these chondrogenic cells develop, and we have then these chondroblasts. Chondroblasts produce matrix, and when they get surrounded by the matrix, they actually become chondrocytes. So all of these cells with good developed organelles are chondrocytes. And chondrocytes, when they sometimes group themselves in these groups of 2, 4, and also 8 cells, and they start forming these groups or nests of cells surrounded by special ECM. And this group is called the isogenic group. Isos meaning the same, basically indicating the equal origin of these cells. But this group is also called a lacuna. This lacuna has these two cells, or it can have 4 cells, and then these are chondrocytes. So chondro. The chondrocytes have this connective tissue, small amount of connective tissue that surrounds them. This is called the pericellular capsule, and it shields these cells from damage. Then there is this layer. This layer has less fibers, and it is a little bit lighter in color. This layer is called the territorial matrix. The territorial matrix. Together, the territorial matrix and these cells, this is called a chondron. So this is called a chondron. The remainder of the matrix that is left is called the interterritorial matrix. So the interterritorial matrix. So this is the basic structure of cartilage. And we have seen what the basic cells in the cartilage are. Now we will take a detailed look into the matrix, because these cells, their main function is to produce this matrix. So in the matrix, we can actually, the extracellular matrix has 2 main types. The first type of elements are proteins plus water. And the cartilage has a lot of water. the water can be bound or free, but proteins make up about 10% and the water in the cartilage makes up about 70 to 75%. So a lot of the structure of cartilage is actually water. The second element are fibers. So a network of fibers, either collagen type 1 or 2 or elastin with collagen, is also present. These proteins are very important for the structure of cartilage. And I laid out here one big molecule of proteoglycan aggregate. So here we have many proteins and molecules banding together to form this huge molecule. This central part, the central line, is representing hyaluronic acid. So this is hyaluronic acid. This hyaluronic acid then connects with these triangular proteins, and these are called link proteins. And the link proteins connect the hyaluronic acid with these proteins, and these proteins are called core proteins. And on them we have molecules that are bound to them, and these molecules are called glycosaminoglycans, or GAG. Together they form these aggregants. Which are the main proteins in the cartilage? These GAG molecules have a negative electricity on them, a negative charge, all of them. Why is this important? In the cartilage, in between of these molecules, we have water. So the darker molecules are free water, and the lighter molecule is bound water. So if we have some pressure on our cartilage, the molecules are coming together and the water is being pushed out. But because these molecules are negatively charged, when the pressure is released, naturally they will separate and the water will come back in. This is important, and that is how cartilage is maintaining its shape and structure regardless of the pressure, because it has these functional proteins that can bind water and have these complicated structures. Besides these proteins that are bound in these huge proteoglycan aggregates, there are also proteins that are free. One protein that is free is chondronectin. Chondronectin has this function of binding and connecting collagen type 2 fibers with chondrocytes, making the structure of cartilage more stable. Now, where is the cartilage found in our body? Hyaline cartilage is found in joints, but it has no perichondrium. Then it is found in anterior parts of our ribs and in big airways like the trachea. It is also found in the larynx, in its cartilage, in bigger bronchi, and so on. Then we have the elastic cartilage. The elastic cartilage is found in the auricle and the outer auditory meatus in the Eustachius tube. And then we have the fibrocartilage. Fibrocartilage is found in intervertebral discs and in the pubic symphysis. So it is also found in menisci, in the knee joint. So this is the basic structure histologically of cartilage and its cells and the extracellular matrix. Thank you.